Subscribe my channel for physics, JEE and NEET.
Hello students, good morning all of you. Today in our video I want to explain the chapter. It is oscillations. So this is very important chapter for both the board examinations and also JEE and NEET. So now let us start our topic. So before going to learn about the oscillations, we have to know the basics of the motion of your body. So that is periodic motion. Start with the periodic motion. So what is meant by a periodic motion? An object or a particle or a body can move repeated itself in equal time of intervals. In equal time of intervals. Equal time of intervals is known as the periodic motion. So the motion of a body moves repeated itself in equal time of intervals, then it can said to be periodic motion. For example, all the planets revolves around the sun. So this is the one of the periodic motion. This is the one of the periodic motion, right? And also one more example, it is the uniform circular motion. Uniform circular motion. So these two are the examples of the periodic motion. In this periodic motion, if the particle has to and fro, has maintained the to and fro of motion, then it can said to be oscillatory motion. Then it can said to be oscillatory motion. So in a oscillatory motion, a body can be repeated its motions in equal time of intervals and also having maintained the to and fro of motion. To and fro of motion, it means if there is a particle here, it will moves in this side and come back and reaches its point. So in this type. So in this way and in this way. Or if this particle can be moving in upward direction and the downward direction. So from this, it is these type of to and fro motions are called oscillations. The most important point here you have to remember, that is all the oscillatory motions, all the oscillations are periodic motions. All the oscillations are periodic. Very, very important. All the oscillations are periodic. So the example of the oscillation, it is the motion of pendulum in a clock. And one more example, it is the needle in a sieving machine. Needle in a sieving machine, which is used to stitching the clothes. So the needle in a sieving machine can shows the oscillatory motions. All the oscillatory motions are periodic. 95% of the oscillations are all belongs to the periodic motions. So what is a periodic motion here? The periodic motion is a particle can move itself repeated their motions in equal time of intervals. Including that, if that particle can have the to and fro motion, then it can said to be oscillation. Okay, so that is the difference between the periodic and oscillatory motion. So one more motion it is there, that is the vibrations. The slight variation between the between the oscillatory and vibration. In case of oscillatory, the frequency is less. Frequency is less. For example, if a branch of a tree can moves small frequency. Whenever the air will be comes, the winds are comes in speedily, then the branches of a tree will be moves. The number of cycles per the unit time is very less. Then the branches of a trees can be moves, or they gives the oscillations. The oscillation is the example of the frequency of that branches are very less. In case of vibrations, the frequency is more. If frequency is more, in this case, the example it is the string in a guitar. If we have to play the guitar, whenever we have to plucking on the string of a guitar, then it can be, so this is the string of a guitar. When you have to use one plucking, so then it can be the more number of cycles are in a unit time, then the frequency is more. Here the frequency is more. If frequency is more, then it can set to be vibration. If frequency is less, then it can set to be oscillation. So this is the very important difference between the vibration and oscillation. Okay, the periodic motion, it can be repeated itself in equal time of intervals. That is the periodic motion. Okay. So along with the periodic motion, if it can shows the to and fro motion, that motion it is the oscillatory motion. So these are the types of the motion of a particles. Now we have to learn about the chapter name, it is oscillations. In this, the specific nature of an oscillatory motion, that can be SHM, simple harmonic motion. The specific nature of the oscillatory motion. The simplest form of the oscillatory motion, it can be simple harmonic motion. So in this chapter we are learning very well about the simple harmonic motion. Let us see. Okay. Here, a particle which can be repeated itself in equal time of intervals, it can be moves repeated itself in equal time of intervals, it has the periodic motion. Along with the periodic motion, a particle can be follows the to and fro motion, either left or right, either up and down, or maximum to minimum. Okay, so this type of motion, it is the oscillation. Okay, so here we need to know about the simple harmonic motion. Simple harmonic motion, it can be simply says that SHM, simple harmonic motion. So in case of a spring, so here this is a spring having the mass, loaded mass, that is the M. Whenever it will be pulled down, and then it will be the force will be acting in upward, and the displacement will be in downwards. So then the force acting on that spring F is directly proportional to the minus X, and then F is equal minus Kx. This is the force acting on the loaded spring. So here the rigid support when you have to hanging the spring, right? So in case of simple harmonic motion, the particle can be moves must be to and fro. So the first point to remember or to define the simple harmonic motion, the first point, it is the particles are moves to and to and fro motion. To and fro motion with fixed axis, with fixed point. With fixed point. So that point is known as the, what is that point? Origin, or it is nothing but mean position. Or it is nothing but mean position. So this is the first point to obey the simple harmonic motion. The second point, it is the motion of the particle. Motion of the particle is always towards mean position. Always towards mean position. The motion of the particle always towards the mean position. This is the second point to obey the simple harmonic motion. And the third point, it is the acceleration of the particle. Acceleration of the particle is directly proportional to the displacement of the particle. Displacement of the particle and negative in nature. So here in equation we can write that A directly proportional minus X. This is a very important key point to maintain the SHM. To maintain the SHM, very important. A proportional minus X. If the displacement of the particle is negative, then the acceleration of that particle is positive. Right? If the displacement is negative, then acceleration is positive. Similarly, vice versa. If the displacement is positive, the acceleration is negative. So this is the meaning here where they are in opposite nature. So these are the points to obey the simple harmonic motion. If a particles are moves to and fro motion with fixed point, and motion of the particle is always towards the mean position, and that is the equilibrium position, and acceleration of the particle is directly proportional to the displacement of the particle and negative in nature. These are the points to remember the simple harmonic motion. So from this we can write that the simple harmonic equation, that is A is directly proportional to minus X, is comparatively F is equal to minus Kx. It means F is proportional to the minus X. Then all of you note it. All of you note down or take it as screenshot and make a notes. And now, so now we can write. So here from the Newton's second law, F is equal to ma, where A it is equal to F by m. A is equal F by m here. Okay. So then what do you have to write here? Where it is the F is equal minus Kx. From this you can write A is equal to minus omega square into X. From A proportional minus X. So if proportional will be removed, then omega square is taken as the constant. How we can take as the omega square as constant? Let us in our next topic we have to see. Okay. So then here F is equal to minus Kx. So this is the equation 1 we have. This is the equation 2 we have. So from this we can write A it is equal, F is equal ma here. Ma it is equal minus Kx, where A it is equal minus K by m into X here. So this is the equation we have to compare. This is 1 here now and this is 2. From these two we can write that where A and A, LHS is equal LHS and RHS will be where omega square it is equal K by m. Omega square is equal K by m here. So omega it is the angular velocity, it is under root of K by m. Under root of K by m. So K it is the spring constant here and m is the mass of the body which we have to tagged. Okay, so from this we can write that, omega square it is equal a by x, omega square is equal a by x, and omega is equal to under root of a by x. So a it is the acceleration, and x it is the displacement, so under root of acceleration and by the displacement. So this is the angular velocity here. Okay. So now we have to derive an expression for the simple harmonic motion, and also we have to find the motion of the simple harmonic motion, how the velocity and acceleration will be changes. Let us see. Okay, let us note it. Right. So here a particle, let us take a particle at the main position. This is the main position, and this is the one of the extreme point of the right side, and this is the another. So the particle is moving this side of the left extreme, so we have to take the left extreme. Okay, so this is the particle. This particle can be moved to and fro, this extreme to mean and extreme to mean and extreme. So this is the process, the motion of the particle here. So the position is here, this is the mean position. The position of the particle is mean position. That is nothing but equilibrium. At the equilibrium point or the mean position, the displacement of the particle is zero. Very, very important. So the distance or the displacement will be measured from the only the mean position. Displacement measured from only its mean position. Displacements are the only measured from its mean position. Okay. So at the mean position, the displacement of the particle, it is the zero. So this is the positive x-axis and this is the negative x-axis, right? This is the origin or the main position. Now here the particle is here. At this point, the final velocity of the particle is zero. Because of at this point the particle will ready to come back to the main position. So when it will be come back, whenever its velocity will be equal to zero, then only it will be come back. If the particle is moves in this side and it will be come back, then it will be stops here, and at the same time it will be started to come back to the main position. Okay, at this position the final velocity of the particle is equal to zero, and now the forces will be acting in this side. The forces will be pulled aside. So if this is a particle, whenever it will be moves this side, it will be come back in this direction, right? At this point the velocity equal to zero, and it will be force will be acting. That is the direction of the acceleration. Okay. Here the velocity will be 0 to increases, and maximum at the main position. The velocity should be maximum at main position. So V should be increases. So this arrow mark indicates the velocity should be increases when it will be come back from the extreme point. So this is the acceleration, direction of the acceleration, right? And it will be reaches the mean position. At the mean position V will be maximum here. And the net force acting on the main position, what is the net force acting on the main position? Whenever we have to take a spring, of loaded mass M, so then F is equal minus kx. At the main position, whenever we have to Until we cannot apply any force, then x it is equal 0. Where at mean position x is equal 0 or equilibrium position x is equal 0, then f net is equal 0. F net is equal 0. K into 0, it is 0. So here the force F net at the center point or at the origin or the main position is equal 0. What is the 0 value? That is the F net, and net force acting on the particle at the main position. Clear? Right. Now the particle has the maximum velocity and it will be moves in this side. So here it will be reaches the maximum position. So then the force should be acting in this side. So then the particle moves towards the mean position. So from this it moves towards the mean position. So then the acceleration is in this direction. Okay. Now the velocity should be increases here. So of course, if the particle moves in this direction, in this motion, the velocity decreases here, because of it will be reaches the velocity decreases and until it can be getting the velocity is equal to 0. At the extreme point, the velocity is equal to 0. And it will be back and reaches the main position, velocity is maximum. And it will be goes in this side, the velocity is minimum, and come back maximum and reaches 0 and maximum 0. So this is the motion of the particle here. We have to learn, right? So now the particle is come back in this side. The velocity will be increases. And acceleration is in this side. Okay. And now the force is acting in this side, it will be reaches. The acceleration is also in this direction. The velocity will be decreases. Okay. At maximum point, velocity is 0. The velocity should be increases and reaches maximum point, and it will be decreases and reaches 0 point, and it will be increases and reaches maximum point, and decreases reaches minimum point. Right? So these are the arrows we have to write here. Okay, so at mean position, the acceleration of the particle. So already you know that the acceleration of the particle in SHM is directly proportional minus x, and A it is equal minus omega square into x. At the mean position, x is equal 0. At mean position, x is equal 0, then A it is equal, what is that? 0, because of something into 0. Is equal 0. A is minimum here, nothing but 0. V is minimum here, nothing but 0. V is minimum here, nothing but 0. Then at the extreme positions, the A is maximum. And the extreme position A is maximum. But the extreme position velocity is minimum. At minimum point, at the mean position, the velocity is maximum, but the acceleration is minimum, that is equal 0. So these are the variations of the simple harmonic motion, where whenever the particle can be moves from the mean position to extreme and extreme to mean position. Clear? So this is the method. And the simple harmonic motion, it is the simplest method of the oscillatory motion, where A it is equal minus x to the power n. So this is the basic formula we have to learn about the SHM, where n it is the 1, 3, 5, 7, all the odd numbers. If x is positive, so positive power n means odd number. So positive power n, so it means x is positive, it is equal A, it is equal minus plus x to the power n, according to this. So then plus into minus, it is minus x to the power n. So A it is equal to negative. So A it is equal, if x is equal positive, A is equal to negative. Clear? Similarly, if x is equal positive, then A is equal, how we can write, minus of x to the power, x is equal negative here. If x is equal negative, so minus x to the power n. So what happens to, you have to take x is equal negative value. So if x is equal negative value in this equation, minus x to the power n, minus x to the power n. N is the odd number. N is the odd number here. So negative power of the odd, it is equal negative. So then negative into negative is positive. There a it is equal x to the power n only. So minus into minus plus, plus x to the power n. So therefore a it is equal positive. A is equal positive. It is meaning that if x is equal positive, a is equal negative. If x is equal negative, a is equal positive. So this is the a is directly proportional minus x here. This is the a is equal directly proportional minus x here, and opposite in nature. And opposite in nature. Clear? So this is the negative means negative x-axis. Positive means positive x-axis. This is the positive x-axis. In the positive x-axis, acceleration is negative. In the negative x-axis, acceleration is positive. This is the meaning here. Okay? So this is the simplest form of the simple harmonic motion you have to remember. Now we have to learn about the characteristics of the simple harmonic motion. Okay? Let us see. Now let us see the characteristics of oscillations. The characteristics of the simple harmonic motion. Okay? So here, so what are the characteristics of simple harmonic motion? There it is. Characteristics of SHM. First one, it is the displacement. So the displacement of the SHM particle. The displacement, it is nothing but, so already we seen that here this is a particle here, this is the mean position, and this is the extreme which is right side. Okay, this is the another extreme which is left side. Okay, this is also extreme. So here the displacement is measured by the shortest distance between particle and to the main position. So this is the displacement of the particle here. So first suppose here the particle is moving in this direction. Here there is a particle. Now the distance between these two particles. So for suppose this is the particle at position A. The distance between these two particles is the displacement of the particle. Okay, displacement of the particle. The displacement must be find out or measured from the main position only. So this displacement is, this distance was measured by at any instant time. So here what I am saying, it is the distance between main position and to the position of the particle at any instant time. So that is the displacement. That is the displacement of the particle. So here at mean position, the displacement is equal to x mean, it is equal to 0. So already we seen that when x mean it is equal to 0. At an extreme point, any extreme, either it is left side or it is right side, x extreme is equal to plus or minus a. If it is the right side extreme along with the positive x-axis, then it is the plus a. If the particle moves in the direction of the left side extreme point, that is minus a. So this is the maximum displacement. The maximum displacement is minus a according to the left side. The maximum displacement is plus a according to the right side. Okay, this is the displacement of the particle. At the mean position, the displacement of the particle is equal to 0, and at the extreme point, the displacement of the particle is plus or minus A. The displacement was measured from the mean position only. The mean position only. So here the displacement of the SHM particle was defined by the shortest distance between mean position and to the position of the particle at any instant time. At any instant time. Okay. Now let us see the second one. This is the first one. Now let us see the second one, which is nothing but amplitude. Which is nothing but amplitude. So second one, it is the amplitude. Was denoted by the letter capital A. So here the amplitude of the particle. Okay. The maximum distance traveled by the maximum distance traveled by the particle from its main position. From its main position. The maximum distance traveled by the particle from its main position is called its amplitude, the maximum displacement. So not just a displacement, it is the maximum distance or maximum displacement, the maximum distance traveled by the particle from its main position. So if the maximum displacement is at an extreme position, that is x is equal to a. So in this side, the maximum displacement x is equal minus a. Okay. So this is this amplitude. So at the maximum amplitude at an extreme point, so x it is equal, x maximum it is equal a. X maximum is equal a. That is the amplitude. The distance between the mean position and to the maximum point, whatever it will be, moves. Okay. So that is the amplitude. It will be measured in centimeter or meter. Centimeter or meter. And next one, the next characteristic, that is the time period. Next characteristic, that is time period. Okay. So time period, it is capital T. The time taken to complete one oscillation. The time taken to complete one oscillation is called its time period. To complete one oscillation. So how we can find the time period of the pendulum or any particle in i.e.SHM? So this is the point where it was started. So it will be reaches this point, and it will be reaches mean position and goes extreme, and again it will be reaches the same point. So this is the time period. So how we can define the time period? So here the time period it is wherever it will be started, where there is it will be started, it will be reaches extreme point and come back, reaches mean position and goes extreme and reach the same position. So here two extremes are covered in 4 quadrants. So this is 1, 2, 3 and 4. This is 1, this is 2 and this is 3 and this is 4. Okay, so the total time taken to complete one oscillations. So that is the capital T. So here this is the T by 4 and this is T by 4 and this is T by 4 and this taken T by 4. The total time it is equal T by 4 and plus, so that is how many 4 T by 4s are there? That is 4 T by 4. It is equal T. So the total time taken to complete one oscillation, it is equal T. So T it is the time period. So here the time period will be also written as, so it is time, it is equal distance by distance by velocity. So in the circular motion you can write that the distance of, so how many, so if it is a particle having in the uniform circular motion, so then it will be complete for one oscillation there is 2 pi radian. So the distance it is equal to 2 pi radian or 360 degrees, and the velocity it is the angular velocity, and the velocity it is the angular velocity, that is omega, where t is equal to 2 pi by omega. T is equal to 2 pi by omega. So this is the time period of the SHM particle. So already you know that omega it is the angular velocity, that is nothing but which is acceleration by x, under root of acceleration by x. It means acceleration by displacement of the particle. Okay. So this is the formula to find the time period. It was measured in the second. It was measured in second. Okay. So one more important time characteristic, that is the frequency. That is frequency of the SHM particle. So that is the frequency denoted by the letter F. So the number of oscillations, the number of complete rotations per event time. So that is the number of oscillation per event time. So F is equal to 1 by T is the frequency. Here F is equal, already you know that T is equal to 2 pi by omega. 2 pi by omega. Let us substitute here. F is equal to 1 by 2 pi by omega, where it is equal, F is equal omega by 2 pi. Omega by 2 pi. So this is the frequency of the particle in a SHM, omega by 2 pi. So this can be measured in second inverse, or simply it can hedges. Simply it can hedge. Okay. And now let us see the velocity of the particle which is in a simple harmonic motion. Velocity. The fifth characteristic it is velocity. So how we can define the velocity of the particle? So the displacement of the particle x is equal to, you can write that a sine omega t plus phi. A sine omega t plus phi. So this is the basic equation, basic displacement equation of the SHM particle. So it can be measured, or it can be find out from the projection of the particle in a uniform circular motion. The projection of the particle in a uniform circular motion, we have to derive this one. We will be explaining in our next video. Okay. So don't confuse. So the x it is equal a sine omega t plus phi. You have to learn it. We have to must learn it. So a sine omega t plus phi. So whereas we have to find the velocity, just to derivate the equation on both sides with respect to the time. So it is d by dt of a sine omega t plus phi. A sine omega t plus phi. So dx by dt will gives us the velocity, and a sine omega t is derivation, it is the cos omega t plus phi, and omega t it contains omega. Phi d phi by dt is equal 0. Here there is no time variant. Okay. So hence you can derive the cos omega t is sin omega t is derivation by cos omega t, and omega t is omega. So now v is equal to a into omega, a omega cos omega t plus phi. V is equal, so here v is equal to a omega cos omega t plus phi. So this is the velocity of the simple harmonic particle, SHM particle, velocity of the simple harmonic particle. Okay. So here you can write that from this one, whereas sin square omega t plus phi plus cos square omega t plus phi is equal to 1. Sin square omega t, it means sin square theta plus sin square theta plus cos square theta is equal to 1. Then cos square theta, it is equal to 1 minus sin square theta. Clear? 1 minus sin square theta. From this we can write that. So I have to remove this. Right. How we can write that? Whereas v is equal to a omega cos omega t plus phi should be written as, whereas cos theta square should be under root of 1 minus sin square theta. So it is under root of 1 minus sin square omega t plus phi here. Under root of sin square omega t plus phi. Okay. From this we can write that sin omega t plus phi is equal to x by a. From this we can write that sin omega t plus phi is equal to x by a. So then a omega under root of 1 minus x by a whole square. How we can write that x by a? From this one. X by a should be come this side, and sin omega t plus phi is equal to x by a. Sin omega t plus phi, sin square omega t plus phi is equal to x by a whole square. So let's simplify here. A omega under root of a square minus x square by a square. Here x square by a square, and a square will be LCM. A square minus x square by a square. And here the square root and square will be cancelled out. Here a square, a will be remaining. So a and a will be cancelled out. So then what is the remaining value here? So here a omega under root of a square minus x square by a, because of square and root will be cancelled out. A and a will be cancelled out. Here omega into under root of a square minus x square. So this is the velocity of the particle in a SHM. Very important. Velocity of the particle in a SHM. So what is the velocity of the particle at mean position? The velocity of the particle at mean position, it is equal maximum. Already you learned it. And the velocity of the particle at the extreme position, v is equal to minimum, it is equal to 0. Because of at extreme position displacement is equal to how much? A. So let us extreme position, we have to calculate the velocity. If x is equal to a, it means at an extreme. So therefore we can write v is equal to omega into under root of a square minus a square. X is replaced by a. So a square minus a square is equal to 0. Omega into 0, 0. So then v is equal to 0. So at an extreme point, velocity of the particle is equal to 0. Clear? At extreme point, the velocity of the SHM particle is equal to 0. So what is the velocity of the particle at mean position? At mean position, v is equal, at mean position, x is equal to 0. Right? Omega into under root of a square minus 0 square. It is omega into root of a square. Square and root will be cancelled out. Omega a. So v is equal to omega a. This is the maximum value of the velocity of the particle. Maximum velocity of the particle in a SHM. So this can be put it as plus or minus omega a. Why we have taken plus or minus? So here the particle is at any instant time, if it is in a random motion, not at the exactly at the mean position and not exactly at the extreme point. Except these 2 points, the particle is moving between these 2 points. If particle is here, then this may be go this side and this may be moves this side. So there is a chance to positive and there is a chance to negative. Hence we can write that plus or minus of omega a. So the V maximum, it is equal plus or minus omega a. So this is the maximum velocity of the particle in a SHM. Clear? So in simple harmonic motion, the maximum velocity of the particle V maximum is equal, you can write here V maximum is equal V maximum is equal plus or minus omega A. Okay. At an extreme point, V minimum is equal 0. V should be 0. That is the final point also. Mean position is the equilibrium position here. So at the equilibrium position, the net force is equal to the 0. Okay, how we can find the velocity? Clear? Right. Now we have to find the acceleration. So one more characteristic of the simple harmonic particle, that is acceleration. So this is the sixth one, acceleration. So acceleration A. So the velocity of the particle, it is equal A omega cos omega t plus phi. Right? A omega cos omega t plus phi. Because of x is equal A sin omega t plus phi. From this we have to derivate dx by dt, then you can get the v. Okay, so now where dv by dt with respect to time you have to derivate the above equation, then d by dt of A omega cos omega t plus phi, So here no more confusion, we have to derivate one time. If the displacement will be derivated by with respect to t, then velocity will be getting, and the velocity will be derived by time, we can get the acceleration. Okay, the rate of change of velocity, the rate of change of displacement, that is the velocity. The rate of change of velocity is the acceleration. Clear? So now we have to derivate cos omega t plus phi. So omega t is the theta here, and phi is the phase. I will be explaining in our next video what is the omega t and what is the phi here. Right. So here A omega should be outside, and cos omega t plus phi. So the derivation of the cos omega t, it is the sin omega t plus phi. And omega t is derivated by the omega. Omega t is omega. Phi it will be equal to 0. So omega into omega square, now minus will be A omega square sin omega t plus phi. A omega square sin omega t plus phi. Clear? So this is the acceleration. So already you know that A sin omega t plus phi. This is the x here. So then you can write that minus omega square x. A it is equal minus omega square x, because of since x is equal A sin omega t plus phi. From this you can write that A sin omega t plus phi is equal omega square x. So this is the acceleration of the simple harmonic particle, which is at first we have to write. Starting we have to write A it is equal minus omega square x. So from this we can get the A is equal minus omega square x. Omega it is the angular velocity here. Clear? So what is the acceleration value at mean position? At the mean position, x is equal to 0 at mean. So A mean is equal to minus omega square into 0. X it is equal to 0. So then A mean is equal to 0. So at the mean position A it is equal to 0. Already we wrote that. At first we have to explaining A mean is equal to 0. A mean at the mean position acceleration. So now coming to the extreme point. X it is equal to A at an extreme point. So therefore A at an extreme is equal to minus omega square x replacing by A. So that is the A maximum it is equal minus omega square A, or it is omega square A at the extreme point. So at an extreme point A maximum it is equal omega square A. A maximum is equal omega square A. Right? So V maximum is equal to omega A maximum is equal to omega square A. So this is clear. This is the clear idea about the characteristics of the simple harmonic motion particle. Okay, right? So now let us see the graphical representation of the graphical representations of A and X and F and X and V and X. So now the graphical representations. Let us see the graphical representations in case of acceleration and the displacement, velocity and the displacement, and also force and the displacement. Okay, clear. So here already you know that in case of springs, already explained, F is proportional, first graph, F is proportional minus X, F is equal to minus Kx, F is equal to minus Kx. So here the graph, the graphical representation of the force and the displacement. This is the displacement, this is the force here. This is positive y and this is negative y. Positive x, negative x. So this is the origin here. Right? The graph here, F proportional minus x. It will be always F proportional minus x. If x is positive, F is negative. If F is positive, x is positive. F is positive, then x negative. F negative, then x positive. So this is the rule here. So this is the graph, the straight line, which is okay. So what I am saying here it is, if x is positive, so then so this is the force. F is negative, minus F. So this is plus x. Okay. If F is positive, this is a positive F. Then x is negative. X is negative. Clear? Say straight line which is passing through the origin. Okay. And coming to the graph between the A and X. Second graph, it is the A versus X. A versus X. Right. So A proportional minus X and A it is equal minus omega square X. So here also, if A is positive, A positive, A is equal positive, X is equal negative. A is equal negative, X is equal positive. Clear? So same graph which is right plot. So this is plus X and this is minus X, plus Y, minus Y. This is the origin. So which the graph is a straight line which is passing through the origin. So if X is positive, this is the acceleration, this is the displacement. Then the acceleration is negative because of negative y-axis. If A is positive, acceleration is plus A, plus Y. So then it is displacement is minus negative x. Okay, so this is the graphical representation of the force versus displacement, acceleration versus displacement. Now we have to see the velocity versus displacement. Velocity versus displacement, let us see. Okay, let us see velocity versus displacement. And now let us see V versus X graph. And third one it is V versus X. V versus X graph. So V it is equal to omega into under root of A square minus X square. Okay. So V square it is equal to omega square A square minus X square. Here V square by omega square it is equal to A square minus X square. V square by omega square plus x square, it is equal to a square. So v square by a square omega square and plus x square by a square, it is equal to 1 here, because of we have to multiply it by divided by the a square and a square and a square on both sides. So okay, this a square will becomes this side, a square omega square x square by a square, it is equal, here there is 1 only. So here now we have to write that v square by a omega whole square plus x square by a square, it is equal to 1. So this is the equation which is belongs to the, so that was the equation, it is x square by a square plus y square by b square, it is equal to 1. So this is the ellipse. This is the ellipse. The basic equation of the ellipse. So here the graph it is. So this is y-axis and this is x-axis, and here the ellipse. It is the ellipse here. So this is the v and this is x. So x it is equal at maximum a and v it is equal at maximum a omega. So this is the origin. Okay, the plot of the v versus and x, it is the ellipse. Okay, and a versus x, it is the straight line, and f versus x, it is the straight line which is passing through origin. Okay, and now let us see. So here, if there is in this equation, if omega square or omega is equal to 1, then what will be happen? If omega is equal to 1, then we can write that v square by a square omega square plus x square by a square, it is equal to 1 here. So omega square 1 square. So here it is written as, that is v square by a square plus x square by a square, it is equal to 1. V square plus x square, it is equal to a square. Okay, v square or v square plus x square plus it is equal to a square. So this is the straight line. This is the equation of circle. This is the circle. Okay. So if omega it is equal to 1, then the plot between the v versus x, it is the circle. If v versus x, it is the ellipse. So this is the variation you have to remember here. And now let us draw plot between a versus v, the graph between a versus v. So how we can write? So a versus v. So here a, it is the omega square x. A, it is equal to omega square a, at a is equal to omega square a or omega square x. You have to write that omega square x. So x, it is equal to a by omega square. X is equal to a by omega square. But v, it is equal to omega into under root of a square minus x square. Clear? V square, it is equal to omega square into a square minus x square here. So let us write x value. It is equal to omega square into a square minus, what is that? A by omega square whole square. A by omega square whole square. So now let us write here v square by omega square is equal to a square omega to the power 4 omega square whole square minus a square by omega power 4. So it is omega power 4, it is LCM omega power 4 a square minus a square by omega power 4. So how we can write that? So here you need to write where it is. Let us write v square V square by omega square. So here it is the okay V square by omega square and plus a square by omega power 4 it is equal to a square. Clear? Okay. How we can write that? So here minus a square by omega power 4 will be this side. This can be plus a square omega power 4. So here there is remaining a square omega power 4. A square omega power 4. Okay. A square omega power 4. Right. Now let us write here v square by omega square. Omega power 4 and omega power 4 will be cancelled out here. Only a square is there. So v square by a square omega square plus a square by a square omega power 4 it is equal to 1. So we have to, this a square will becomes this side. So v square by a square omega square plus a square by a square omega power 4 it is equal to 1. Okay. So now this can be simplified a omega whole square and plus a square by a omega square whole square. Okay. So this is equal to 1. So this equation should be v square. It is, what is that? This is in the form of ellipse. This is also in the form of ellipse. So that is x square by a square plus y square by b square it is equal to 1. Okay. Similarly, the graph which is equal to the velocity versus x. So that is the ellipse. Clear? So the graph between the a versus v is equal to the v versus x. The shape of the graph, it is the ellipse here. Okay. Right. A versus v. So here the graph it is. Here it is right. It is the graph. So this is the ellipse here, where it is v. This is a, and here a omega square. It means omega square a. It is maximum velocity. It is a omega. So this is the origin. So the shape of the graph it is the ellipse here. Okay. Right. Now let us write the graphs between displacement and time. Very important. Displacement and time, and also velocity and time, and also acceleration and time. So graphs between xt, vt, and EAT. So displacement and time, velocity and time, acceleration and time. So here the graphs are, we have to write one straight line for all graphs. At first I need to write xt graph. So on x-axis we have to take time. So this is the xt graph. This is the xt. So this can be, what is that, t by 4, and this can be t by 4 plus t by 4. It is t by 2, and this can be, so it is here 3t by 4 here. Okay. Right. So this is the origin where it is x here. So x it is equal, you can write that a sine omega t here, or omega t plus phi here. A sine omega t plus phi. And coming to the vt graph. So this is the vt graph which we have to draw. This is the vt. So where we have to write the length of the vt. So this is the vt graph. Okay. So this is t by 4. and this is t by 2 and this is 3t by 4. Okay, so here V it is equal to a omega cos omega t plus 5, a omega cos omega t plus 5. So this is the time, and this is the origin where this is velocity, this is velocity, this is displacement. So now the graph between acceleration and to the time. So this is the acceleration. Now we have to start with this one. So therefore you can write it and draw this. So in this manner, right? In this manner. So this is t by 4 and this is t by 2 and this is 3t by 4. So this is the time. And acceleration a is equal to minus a omega square sine omega t plus 5 here. Okay, and this is the acceleration in this. This is the origin. So these are the graphs of very important graphs of the xt, vt and the at. So it is start with from here, and it is the velocity graph start with from here. So this is the graph, and the acceleration graph start with from here. So this is the acceleration graph. Okay, so this is x and this is v and this is a. So these are the starting point of the graphs between xt, vt and at. Okay, so now let us see one more important characteristic, that is the average speed and average velocity of the SHM particle. So already we discussed reveal about the velocity of the particle at mean position and also at extreme point. So now let us see. So all of you done this. So please note it. Please note it, all of you. Right. Now let us see the average speed and the to the average velocity. Average speed and to the average velocity. So average speed and average velocity. So for one rotation, for one complete oscillation, for one complete oscillation, the distance traveled by the distance traveled by the particle is equal to 4a. So this is the particle which is at mean position. At first it will be reaches the extreme. So this is the extreme. It is a, and it will be reaches again a. It will be reaches another extreme. This is a, and it will be come back the same position. So this is a plus a plus a plus a. So these are the 4a. So the distance traveled by the particle, it is the 4a. So for one complete oscillation. So one complete oscillation is it will be gives the same position. It will be reaches same position where the displacement it is equal 0 here. Displacement 0. The distance covered by the particle, it is 4a. Right. So therefore average speed is equal V average is equal to total distance by total time. So that is equal total distance, it is equal 4a, and total time it is equal one time period. To complete one oscillation, it is the time period. So this is the V average. So how you can write that? So T is equal 2 pi by omega here. Let us V average, it is equal 4a by 2 pi by omega. So it will be simplified 4a omega by 2 pi, and it can be 2 cancelled out. So it is 2 times of 2 by 5 a omega. So V average it is equal 2 by 5 A omega. 2 by pi A omega. So A omega, it is the V maximum. V maximum. At the main position, V maximum, it is equal A omega. Okay. So then you can write that V average, it is equal, therefore V average, it is equal 2 by 5 V maximum, 2 by 5 V maximum. So this is the average speed of the particle to complete one oscillation. Okay, clear? So this is note point, you have to note it. And now let us see average velocity. So the average velocity, it is nothing but the total displacement by the total time. The displacement of the particle, where to complete one oscillation, the displacement will be same. The position will be same to complete one oscillation. Here the displacement is no displacement. So displacement is equal to 0. Then the average velocity is equal to displacement by time, 0 by time, it is equal to 0. The average velocity is always 0. Very, very important. The average velocity is always 0 because of the displacement of the particle for completing of one oscillation is equal to the 0. The displacement of the particle is equal to 0. So here there is no displacement, but the path distance or the distance covered by the particle, it is the 4a, right? So here the path length should be measured as the distance between one extreme to another extreme. This is the path of the particle. One extreme to another extreme, that is the path of the particle. Okay. So here the average speed, it is the 2 pi V maximum. Average velocity is equal to the 0. Why? Because the displacement at the main position is equal to 0. X is equal to 0. Clear? And now we have to find the acceleration and in case of V maximum and A maximum. Okay, V maximum and A maximum. So that is, just you have to write. So all of you note it. Now the expression for the time period and amplitude in case of maximum velocity into the maximum acceleration, in terms of maximum acceleration and maximum velocity. So here time period T and A in terms of V maximum and A maximum. So A maximum, it is the acceleration. Okay. So here V maximum, it is equal to A omega, and A maximum, it is equal to omega square A. Now V maximum by A maximum, it is equal to, you can write A omega by A omega square. A and A cancel, omega and omega cancel. Okay, clear? So it is the 1 by omega. So omega is equal to 2 pi by T, so then it can be written as T by 2 pi. Omega is equal, because of T is equal to 2 pi by omega, and omega, it is equal to 2 pi by T. Here 1 by omega, it is T by 2 pi. Okay. So V maximum, it is equal V maximum by A maximum, it is equal T by 2 pi. Okay, T by 2 pi. So T is equal, you can write that T is equal 2 pi into V maximum by A maximum. This is the equation of the time period in terms of V maximum and A maximum. Okay, T is equal to 2 pi into V maximum by A maximum. That is the time period. How we can get that? The V maximum is equal to A omega, A maximum is equal to omega square A, V maximum by A maximum is equal to 1 by omega, it is equal to T by 2 pi. So T will be 2 pi into V maximum by A maximum. Clear? Now, but another equation where V square maximum by A maximum, it is equal to V square, it is equal A square omega square by A maximum, it is equal omega square A. So now omega square gets cancelled, square and A will be cancelled, remaining A will be there. So V square maximum by A maximum, it is equal amplitude. So amplitude should be written as V square maximum by A maximum. Time period should be written as 2 pi into V maximum by A maximum. Clear? So these are the observations we have to calculate in numericals, right? Now let us find the velocity and the acceleration at various points. Velocity and acceleration at various points. Okay. So that is here at mean position at x is equal 0. At mean, here it is at mean position, V maximum, V is equal at mean position x is equal 0, V is equal how much? A is equal how much? V it is equal maximum, so that is equal A omega. Okay, and A it is equal A is equal at the mean position, A is equal 0. Because of V it is the omega into under root of A square minus x square. If x is equal 0, then V is equal A omega. A square whole square, it is square and the root will be cancelled, it is V maximum. Similarly, A it is equal omega square x. If x is equal 0, then A it is equal 0. So this is the mean position. Where x is equal to A by 2. If x is equal to A by 2, the displacement of the particle. For suppose here the displacement of the particle, this is the extreme and this is the another extreme. This is 0, where this is the A by 2. If the displacement is A by 2, so then what is the velocity? So how we can find x is equal to A by 2? So then V is equal to omega into under root of A square minus A by 2 whole square. It is A square by 4 here. 4 should be comes this side. Under root of 4 it is equal to 2. Okay. So 4A square, 3A square by, how we can write that? It is A square minus A square by 4. Okay. It is equal to omega into under root of 4A square minus A square by 4. Under root 4 it is equal to 2. It is equal to omega into root 3 A square by 2. So it is equal to omega into root 3A by 2. So it is equal to V maximum. V it is equal to root 3 by 2 omega A. So that is this is the V value where x is equal to A by 2. But if x is equal to A by 2, then A it is equal how much? Omega square A by 2. Clear? What is the values we have to write that? And next, if x is equal root 3 by 2a, so in case of root 3 by 2a, you have to substitute here and write the V value and omega square value. So omega and the acceleration value, it is the A, it is equal, directly we have to write that A, it is equal omega square root 3 by 2 A, root 3 by 2 A, simple. So that is the acceleration value. Okay, so if it is root 3 by 2, if it is root 3 by 2, so then you can write V is equal to 1 by 2 omega A, 1 by 2 omega A. So these are the different values where different position of the particle. Okay, if x is equal to A, if x is equal to A, that is the extreme point, V should be maximum, that is equal A omega. If x is equal to A should be, if x is equal A, at extreme point, A should be, what is that? Omega square A. Right now, so these are the values where the velocity and the acceleration of the particle, SHM particle at different positions. Okay, so these are the different points you have to cover in the simple harmonic motion. So this is very useful video. We have to focus on this video. And now let us see some examples. Here, so question 1. If the particle is making an angle with the theta is equal 45 degrees here, theta is equal 45 degree, then find. So this is the displacement and this is the, what is that, acceleration. Find the time period. Okay, find the time period. So here we can write that, what is that, A, it is equal acceleration omega square x, A is equal omega square x. Here omega square it is equal tan 45, omega square it is equal tan 45, here it is equal to 1. Okay, so omega it is equal how much here, 2 pi by t, it is equal to 1, 2 pi by t is equal to 1 because of omega square is equal to 1. So t is equal, time period it is equal 2 pi, time period t is equal 2 pi, what is that, second, time period t is equal 2 pi second. Now, and one more example you have to see here. So dear students, this is the chapter starting of the oscillations. We have to discuss very well about the simple harmonic motion. We will discuss the other components in our next video. Please follow our channel and make sure subscribe. And I am very thankful to you to make 1000 subscribers. Thank you one and all. So please do not forget, subscribe my channel and like, share, comment to your friends. Thank you one and all.